Hello children, welcome to the My Dream. Today we are discussing the mechanical properties of fluids. Yes. Yes, first of all we are talking about the equation of continuity. Equation of continuity. Suppose you are considering a non-uniform pipe in which the fluid flow is laminar. This is the section A, this one is the section B. Here the area of cross section is A1 and the pressure is P1 and the velocity is V. Here the pressure is P2, area of cross section A2, this is V2. So the distance traveled by the fluid at A is given by V1 into delta T. The distance traveled by the fluid at B, that is V2 into delta T. As we know about the density, so mass flux means mass of the fluid flowing, that is density into this. At section A, it is given by rho 1 V1 delta T. So, as the fluid is flowing, we have discussed the distance traveled by the fluid at A is given by V1 into delta T. At this section, the distance traveled at B, that is given by V2 into delta T. The mass flux means the mass of the fluid flowing at section B, which is given by at section A. At section A. Yes. That is given by M1. So M1 is equals to rho 1 V1 delta T. And this is rho is given in terms of area into this delta T, because This is the volume. This is the volume. So density is equals to density is equal to mass oblique volume. So mass is equals to rho into V, and this is A V into delta T. And this is given by M1 by delta T is given by rho A1 V. Similarly, that is given by at B, that is M2 delta T rho 2 A2 V2. Now so M by M1 upon delta T is given by rho A1 V1, whereas M2 delta T rho 2 A2 as the mass flux is same, then you can write down rho A1 V1 is equal to rho 2 A2, that is A2 V2. If the fluid is incompressible, then rho 1 is equal to rho 2. So A1 V1 is equals to A2 V2. Or you can say AV is equals to A constant, which means it can be written down like this. More is the area of cross section, lesser be the, but the rate of flow remains constant. Or you can say volume of the liquid flowing per second. Volume of the fluid flowing per second, or you can say the rate of flow remains same, remains constant, and vice versa. If the area of cross section of that pipe is very much less as compared to other end, then the velocity goes on, velocity increases. Now we are talking about the energy. As you know, the fluid possesses the three kinds of energy. One of them is the kinetic energy, another one that is potential energy of the fluid. First is kinetic energy of the fluid, third one is the pressure energy of the fluid. So consider a fluid of kinetic energy that is given by half mv square. The kinetic energy of the fluid, is defined as energy possessed by the fluid. The energy possessed by the fluid by the virtue of its motion, that is given by. If you want to know the kinetic energy possessed by the fluid due to its motion, by the virtue of its motion, and if you want to know the kinetic energy per unit mass of the fluid, the kinetic energy per unit mass of the fluid, it will move here, that is given by half kinetic energy per unit mass is given by, this is half v square. So this is the kinetic energy of the fluid per unit mass. Next is potential energy. You know about the hydrostatic, you know about the hydrodynamics, the study of fluid at rest, that is hydrostatics. The study of fluid in motion, that is the hydrodynamics. So when we are talking about the hydrostatic, it means we are talking about the potential energy discussed. Potential energy of the fluid. Potential energy of the fluid is given by potential energy mg. Energy possessed by the fluid, at rest. The energy possessed by the fluid at rest, that is given by mgh, that is known as potential energy possessed by the fluid at rest, that is called potential of the fluid. If you want to describe the potential energy per unit mass. So the potential energy per unit mass, which is given by GH. Now we are talking about the pressure energy. Work done, suppose you are having a container like this. Work done on the fluid, by pressure. Work done by the fluid by the pressure, that is given by P delta V. If we want to discuss the mass of the fluid, mass of the fluid is given by rho into delta. This is rho is the density. If you want to discuss the work done by the pressure, energy per unit mass, then you will get P by delta V divided by rho delta, which will become P by, that is P by rho. Next. Now we are talking about the Bernoulli theorem. Bernoulli Principle, Bernoulli theorem. Let us consider a tube of different area cross-section. This is the end A, this is B. Here the velocity is V1, here the velocity is V2. Area of cross-section A1, A2. This is at a height H1. This is at a height H2. So, first of all, we must know about the Bernoulli theorem. As you know about the energy of the fluids, one of them is the kinetic energy, then another one is the potential energy, third one is the pressure. The sum of the kinetic energy, potential energy and the pressure energy per unit mass. The sum of the kinetic energy, potential energy and the pressure energy per unit mass of an incompressible and non-viscous fluid the sum of the kinetic energy, potential energy and the pressure energy per unit mass of a fluid of an incompressible and non-viscous fluid remains constant. So work done on the fluid by the pressure energy is given by P1 by P1 by M by rho, P2 M by rho. Yes. Because this is incompressible, so rho 1 is equal to rho 2. Yes. This is the work done on the fluid by the pressure. Energy is given by this, by P delta V. So increase in kinetic energy is given by half m v2 square minus half v1. Narrow. Yes. Otherwise, you can write down the decrease in kinetic. It will be narrow. So increase in potential energy. Increase in potential energy. mgh2 minus mgh1. So by work energy theorem, you can write down P1 minus P2 m by rho half mv2 square minus half v1 square plus mgh2 minus mgh1. So you can write down P1 minus P2 by rho, that is half V2 square minus half V1 square, that is GH2 minus GH1. M से M कैंसिल, M से बेटे क्या कर दिया हमने, M से M कैंसिल कर दिया. So P1 minus P2 divided by rho, which is half V2 square minus half V1 square, GH2 minus GH1, 1 1. So P1 by rho plus half rho V1 square plus half rho GH1, P2 by rho 1 by 2 V2 square GH2. So it can be written down in this form also, P by rho plus half V1 half V square GH is equal to a constant. So this is the Bernoulli principle or Bernoulli theorem. You have drawn a pipe like this. This is the height h2. Your velocity was v1. This is v2. This is section B. This is A. Here the area of cross section is A1. Here is A2. The pressure is P1. This is P. And now, if the tube lies on a horizontal plane, it means it means H1 is equal to that. Then it will be cancelled. So it will become P1 by rho half V1 square is equal to a constant. Is equal to a constant if it lies horizontally. If it lies horizontally, then you can write down P by rho plus half V square is equal to a constant. Or you can say P1 by rho plus half V1 square is equal to P2 by rho half V2 square. Yes. Now we are talking about the application of Bernoulli theorem, by which we can discuss the rate of flow. It is an instrument by which we can discuss the rate of flow. That is Venturi meter. This is a tube. Here the area of cross section is A1. Velocity is V. Here the area of cross section is A2. Velocity is V. Yes. As the height is same, so as we know the Bernoulli principle, As we know the Bernoulli principle, that is the sum of the kinetic, potential, pressure, energy per unit mass for an incompressible and non-viscous liquid remains same, and which is given by P by rho half rho V square half V square plus GH is equal to A constant. Here P by rho half V square GH P by rho half V square plus GH. This is H2, this is H1, this is V1, this is V2, this is pressure P1 at this section. At this section, the pressure is P. Here H1 is equal to H2. So P1 upon rho plus half V1 square, P2 upon rho plus half V2 square. And it can be written down like this also, P1 minus P2 by rho, and that is half V2 square minus V1. It will go here. So, according to equation of continuity, that is A1 V1 is equal to A2 V2. So in place of V2 you can write down A1 upon A2. Here you can put the value of V2, that is P1 minus P2 divided by rho 1 by 2 square of V2 minus square of V1. Understand? So in place of V2 you can write on A1 upon A2 V1 minus V1 square P1 minus P2 twice of yes. So V1 square common, that is A1 square minus A2 square, take the LCM, that is A2 square. This is, so V1 square is equals to, V1 square is equal to A2 square divided by A1 square minus A2 square twice of this divided by rho. Then you can write down V1 is equals to A2 under root twice P1 minus P2 divided by this A1 square minus A2. This is the velocity at the section A, which is broader. And you want to know the rate of flow. That is Q is equals to A1 V1, that is A2 V2. So A1 V1 in place of V1 you can write down twice P1 minus P2 divided by rho A1 square minus A2. This is the rate of flow. Yes, this is the application of Bernoulli theorem. Now we are talking about the terminal velocity. Terminal velocity, what do you mean by the terminal velocity? When a small spherical object falling in a liquid. In a liquid. It is first accelerated. It is first accelerated. Then the acceleration decreases. Acceleration decreases. And it will become zero. It will become zero. And attains a constant velocity. When an object is falling in a liquid, its first acceleration increases, then decreases until it will become zero. Then it attains a constant velocity. That velocity is called terminal velocity. As it falls in a fluid, three forces act. One of them is the weight, another one is the upthrust force, and a viscous force. So three forces act on it. One of them is ut, this is Fv, and this is the weight. So we can write down, this is the weight, this one is the upthrust, and this is the viscous force. According to Hooke's law, viscous force is given by 6 pi eta r, and the weight of an object is given by mg. This is mass is equal to density into volume. The object is supposed to be spherical. We have already taken the spherical object, that is 4 by 3 pi r cube into this is the weight. Now we are talking about the upthrust. That is the weight of the displaced liquid, that is given by Here rho is the density of an object, and sigma is the density of the medium. Medium can be water, air, or any kind of the fluid. So this is volume, and the density will become sigma. Sigma is the density of the medium. So this force is equal to these two forces. These forces, because they are anti-parallel. So the weight of an object is given by 4 by 3. 4 by 3. Yes. 4 by 3 pi r cube rho g, which is equal to this. That is 4 by 3 pi r cube sigma plus the viscous force is given by 6 pi eta r, and 6 pi eta rv is 4 by 3 pi r cube common rho minus sigma into g. Pi se pi cancel. Now this is 18, 2 to the 4, 9 to the 18 by eta, r se we take r cancel. This is the terminal velocity. This is the terminal velocity. Now, as you got the terminal velocity, that is Vt is equal to 2 by 9 r square rho minus sigma into g by eta. If rho is greater than g, then Vt is positive. Moving towards, it means object goes on towards the center of Earth, or the object is falling. Object is falling. If then terminal velocity will become 0. If rho is lesser than this, the terminal velocity will be negative. It moves upward like a balloon. Like a balloon. For the comparison point of view, for the comparison point of view, V1 upon V2 is equal to R1 upon R2 whole square. For the comparison point of view, V2 by V1, R2 by R1 whole square. So V2 is equal to R2 by R1 whole square into, this is our terminal velocity. Now, terminal velocity, coefficient of viscosity. These are the different layers. The velocity at the bottom is 0. Suppose here the velocity V. This is V plus delta V. So there is a viscous drag, viscous force. So the viscous force is directly proportional to the area of the layer. The viscous force is directly proportional to the area of contact of the layer. Second, the viscous force is directly proportional to the velocity gradient. As we combine these, or as we replace this, A dV by dt, negative sign indicates there is a viscous drag opposite to the flow of the liquid, and here eta is the coefficient of viscosity. Yes. What do you mean by the viscosity? Viscosity is, when we are talking about the viscosity, you can resemble with the friction. In case of solid, as you know, the friction, the force of friction that comes to play when an object is at rest or in motion. These are the different types of the friction: static, limiting, kinetic, rolling, sliding. That means the force of friction that opposes the relative motion of an object. Here also, the force of friction exists between the two layers. In case of solid, when we are comparing it, in case of solid, the friction depends on the normal reaction. Friction depends on the value of normal reaction. When we are talking about the force of friction in solid, that do not depend upon the area of contact between the tires and the road. But when we are talking about the viscosity depends on the area of contact. Viscosity depends on the area of contact. So, whereas viscosity do not depend upon the normal reaction. Understand? In case of friction, when we are talking about the friction do not depend upon the area of contact. It depends upon the normal reaction. Whereas when we are talking about the viscosity depends on the area of contact, not on the normal. In the next session, we will discuss the problem based on fluids. We will discuss the problem based on fluids. Okay, children, have a good day.